All right, lesson 4.5, which is going to be the last lesson for this chapter. So it's short. This one's only 8 questions long. So if I go for 45 minutes this time, then something went drastically wrong. So hopefully this one's a lot shorter. Anyway, because this one is all about solving exponential equations. So there's only 8 of those. And we've actually done this before, so I may actually skip through a couple. But just to refresh our memory on what we're doing, we have an exponential model. It's a equals 802 e to the 0.013 t power, and this describes the population of a country in millions t years after 2003. So 2003 is going to be the year this is based off of. Use the model, predict the country's population. Use the population of the country in 2003. Wow. The first one is muy simple. It wants to know what is the population in 2003. So what we have to remember is this is falling into our exponential growth and decay model. So here it is. A equals a sub naught e to the kt. A sub naught is your original amount, and since they're asking me what is the population of the country in 2003, it's going to be 802. There really isn't any work to this problem. Okay. So the first one took a minute and a half when it only needed to take 10 seconds. That's all right. Here we go. Number 2. The exponential model describes the population of the indicated country A in millions t years after 2006. Which country has the greatest growth rate, and by what percentage is the population of that country increasing each year? All right. So I really wish I could. What's my options here? Well, the best option would be if I would be using some device where I could share my screen. That doesn't work in this particular case. So we have to come up with another method. I could write them all out, or I could see if my phone would actually show them to you. And this is going to be an impossible task. So, punt. We're just going to write them all out. So here's the way. We have 4 countries. We have A equals 1088.4 e to the 0.011 t power. A equals for our 4 countries. We got 131.2 to the 0.004 t power. We've got 25.8 to the 0.028 power, and here I said it wasn't going to take very long. 147.7 e to the negative 0.006 t. All right, so here's the 4 countries that we're looking at, and our question was, which country has the greatest growth rate? So what we have to remember is this k value. That's going to be my growth and decay. If it's positive, it's growing. If it's negative, it's decaying. Okay, so we can look at the last country, and see that the population of country 4 is decreasing. Okay, and our question is, which country has the greatest growth rate? So they are in decline, so we're going to rule out them. So now it's figuring out which one has the greatest growth rate. So this is going to, and again, these decimals have been converted into these fractions, percentages, have been converted into decimals. So this country is growing by 1.1%. This country is growing by 0.4%. And this country is growing by 2.8%. Okay, so the question was again, which country has the greatest growth rate? Well, that is country 3. They are a winner. What rate is it increasing by? 2.8. Okay, so all of that, and that's where we ended up at. Okay, luckily we only have 6 more. So again, just to remember what we're doing, I think we have to solve this one actually. This one's 523.3 e to the 0.029 t power describes the population A of a country in millions of years after 2003. So we're back to that 2003 thing again. But we want to know, when will the population of this country become 990 million? So when will the population be 990 million? So there we go. Again, we're going we're going to solve this exponential equation, and we have to go through the same steps as we did in the other section. We've done this already. So that's why I may skip the next few. Again, we're going to get that e, that exponent isolated. We're going to divide over the 523.3. We want to keep this in my calculator as long as I possibly can. So I'm going to leave it at 990 over 523.3. Okay? And over here on the right, we have e to the 0.029 t power. It's up in the exponent. I got to get it out of the exponent. We're going to get it by being a lumberjack. I'm going to natural log. We're going to chop down the tree. We're going to natural log both sides. So I can rotate this out in front. So this is 0.029 t times the natural log of e. And we love the natural log of e. The natural log of e disappears. So that means the only thing to do to get t by itself is to divide over this 0.29. So we're going to take all this and divide by 0.29. So now it becomes a process of getting that into my calculator. So we have the natural log of 990 divided by 523.3. And then we're going to take this answer and divide it by 0.029. I did not put in the extra parenthesis this time, so we should be golden, 21.98. And it says round to the nearest year as needed. So we're going to go with 22 years. So 2025 would be the year that it wants for an answer. All right. Reached the halfway point 6 minutes later. So this one shouldn't be too bad. In 2000, the population of the country was approximately, tell you what, from years past, I remember I don't like that one. So if you want to do question 4 to get a couple of extra points out of it, you're welcome to do question 4. Other than that, I'm going to exempt it. You know what? I'll rephrase that. I can edit this as I have it. Oh, wait. Can I edit that? Anyway, I'm not going to grade you for number 4. So if you want to skip it, you can. If you want to do it and get 2 extra bonus points, get 2 extra bonus points. Okay? What we need to do is we need to get into number 5 here. In number 5, we have prehistoric cave paintings were discovered in France. The painting contains 6% of the original carbon-14. It uses a model that looks like this. A equals A sub naught, e to the negative 0.000121 t power. To estimate the age of the paintings. Wow. We are stuck. The only thing that we know is we have 6% of the original carbon-14 left. So this is going to be the only time that in math, maybe not, I don't know. We're going to make up numbers. Okay? We're going to make up numbers because we weren't given any numbers. The only thing we were given was we were given that 6% is left. So we're going to make up something that works with 6%. So I'm going to say that we started out with 100, and that means that only 6 those are left. And now we have something that we can work with. Because now we went from 3 unknowns to 1 unknown, and this 1 unknown we can solve for. Okay, we're going to divide over that 100. So we're going to get 0.06 is equal to e to the negative 0.000121 t power. So again, it's that same exact process we've been rolling through. This one just had that different little step at the front. Okay, we're going to natural log both sides. In the process of natural logging, I can bring down the 0.000121. The natural log of e disappears. So to get t by itself, we just have to divide by negative 0.000121. And there we have it. Okay? Stick a fork in it. It is done. Okay? So whatever value that turns into when I type it into my calculator, for time's sake, I'm not going to do it. Okay? We're going to do 6, 7, and 8 and be done. The half-life of a certain substance is 23 years. How long will it take for a sample of this substance to decay to 79% of the original amount? Use the decay model. Oh my gosh. Here we go. What do I know? Again, it tells me the half-life. The half-life of this substance is 23 years. We know that. We want to know how long will it be for 79% of it to remain. Okay, here we go. We have to get, again, we're going to make up numbers again. We're going to roll with that 79%. So that means that we can put a 79 in here. We can put a 100 in here. We have an E, but our problem lies in the fact that I have a K, which I don't know, and I have a T. So I have a problem that has two unknowns. And I cannot work with two unknowns. So that means I have to do something else here. So I guess we're going to have to go work with the half-life. Okay? Again, we're going to make up numbers. Okay? I know it's the half-life. So if I started with 10, that means half of that is 5. I know we're going to have an E. I still don't know what K is. However, I do know that we have 23 years for that to happen. And now a magical thing has happened because how many unknowns do we have? We just have one unknown. So guess what? We can do this. We're going to divide over that 10. We get 0.5 is equal to e to the 23k power. We're going to natural log both sides. In the process of natural logging, I'm going to drop that 23k in front. That disappears. We're going to divide by 23. So now what we have here is we have the natural log of 23, and we're going to divide that, no, oh my God, 0.5 divided by 23. Let's try that instead. Point negative, well, it's decaying, so at least it's negative, so that sounds good. 0.0301. And we're going to hope that 4 decimal places is enough. Now, how did that help me? Well, now I come up here. I used to not know what K is, and I don't know what T is, but now I know what K is. K is a negative 0.0301, and T now becomes my unknown. And now, life is good. I only have one unknown. We can solve for this. Let's roll. Divide by 100, I get 0.79 e to the negative 0.0301 t power. We're going to natural log both sides. So that this is the second verse. It's the same as the first. Nothing here changed. We're just going to roll through with a different variable. So my natural log of e disappears. I'm going to divide over this negative 0.0301, and we're going to have an answer. And we'll go ahead and get this answer just because we can. So we have the natural log of 0.79 divided by, and actually since I have this here, I'm just going to go and insert my previous answer, which is going to be a far more accurate answer. We get 7.82. 7.82. And what does it ask me? Round 1 decimal place as needed. So this is going to be 7.8 years. Okay? The half-life of a certain tranquilizer in the bloodstream is 27 hours. So, in number 7 here, number 7 looks exactly like number 6, excuse me. We're going to use a half-life. We're going to use that half-life to determine. So it tells me my half-life is 27 hours. So again, we start out with some half relationship. And it tells me that half-life is 27 hours. So I'm going to use this to figure out what K is. Then once I figure out what K is, we know that 83% of the dosage remains. So we're going to cut up something with 83%. And then we're going to take this K value, we're going to drop it in there, and then take it times T. So 7 is exactly the same problem as number 6. So I'm not going to do it. 8. 8 and 4 are going to go together. Again, you can nix this. You can do it for a couple bonus problems if you want. But other than that, I'm not going to care if you do number 8. So I'll round this assignment up. Or maybe I will edit them and take them out. No, I'll leave them the same since I've talked about them. Anyway, we're done. Look at that. Only 14 minutes of your life.